Hello and welcome to another episode of AtheroTalk podcast, the podcast series hosted by the EAS Young Fellows. My name is Jan Novák. I'm from the second department of internal medicine of St. Anne's University Hospital in Brno and from the Faculty of Medicine of Masaryk University in Brno, Czechia. And I will be your host for today's episode. And this recording takes place during the EAS 2025 Congress in the Glasgow, UK. And today we will dive deep into the topic of cardiovascular data science and artificial intelligence with our great guest, Assistant Professor Rohan Khera. He is the founder and the director of the Cardiovascular Data Science Lab at the Yale School of Medicine, and at the same time, he is the clinical director at the Center for Health Informatics and Analytics at the same institution. Within his trajectory, he was awarded numerous prizes we will hear about. And Dr. Khera's research focuses on digital phenotyping of cardiovascular disease, for which he uses data-driven strategies and deep learning technologies, using the data from clinical trials, from patients and physicians, and from ECG recordings and from various cardiovascular imaging methods. All of this aiming to improve our understanding of cardiovascular disease and to improve patients' quality of life. So, hello, Dr. Khera. On behalf of the EAS Young Fellows, I would like to thank you very much for accepting our invitation to this podcast. It is a pleasure to have you here today.
Thank you, Jan, for having me here, and thanks to the EAS Young Fellows for hosting this podcast. I'm looking forward to our conversation today.
Yeah, thank you very much for that. And so to start off, could you tell us a little bit more about yourself? So who is Rohan Khera, and where are you from? Where do you live right now? And what are the things you enjoy outside of the professional life?
That's a great start. So I'm Rohan Khera. I'm a general cardiologist and data scientist at the Yale School of Medicine, as you said. I was born in India. I went to school at the All India Institute of Medical Sciences in New Delhi. After my medical school training, I spent a lot of time in various institutions in the US, like the University of Iowa, UT Southwestern, and finally I joined my first faculty job at Yale, which was at the time of the pandemic, and it was a very different time to start, my journey as a scientist and a clinician. In addition to having this academic life, I have a wife and two young kids. My wife's a pulmonary critical care physician, scientist, and I have two daughters, 7 and 3. And so we have a very busy life outside our clinical work. But I do enjoy being outside, so I like biking and running, and join the gym as well. So I think it's been one of the most enjoyable facets of stuff I do.
Okay, that sounds like a very high and tough schedule. And how can you combine this? Can you describe to our listeners your typical day in your life?
Yeah, definitely. So so over time we have found ways in our home life to balance that. If one person is available, the other kind of takes care back and forth. So my day starts typically at 5:30 in the morning.
Wow, that's really soon.
I try and work out from 6 to 7 early in the morning. Then I try and get to work by 8. And it depends on if I'm on clinical service that day or not. If I'm on clinical service, I'm starting clinical work earlier than that even. But if I'm on a research day, then I spend a majority of my day either writing papers, meeting team members, doing analysis in science, or quite frequently now, actually, I'm traveling. So this happens now so that I'm actually working virtually with my team members like I will later today.
Okay, that's really. And do you travel a lot now to the conferences or to meet people?
Yeah, it's a lot of conference travel, a lot of travel to individual institutions to give grand rounds and other meetings of that sort. So there are many speaking engagements that keep me traveling, but a lot of our work started at the time of the pandemic. So we're so used to working virtually that even though people in the lab are not there, I can, after this ends, I'm going to have a meeting with the lab members right after.
Yeah, so everybody knows you are online all the time, right?
Well, yeah.
And we have heard that you started the journey in India, and then you moved to Iowa and Texas universities, and then you continued farther and farther. So can you tell us how this journey went, and even everything happened in the pandemic? So was it smooth or was it difficult on the way?
No, I think I was lucky to go to institution, the All India Institute of Medical Sciences, that had ties to many U.S. institutions. So during my medical training itself, I had the exposure, to be at Hopkins, at UCLA, at Penn, where I spent some time in clinical training, some in research. I also had a chance to spend some time at the NIH. And during these times, there are foundational experiences. I learned that you could combine clinical care, being a clinician, and cardiologist with being a scientist. So, and I think that was the thing that drove me to pursue my clinical training in the US because I knew I could pursue a more diverse clinical pathway. Where my career could evolve into being a scientist as well. So yeah, I would say there were challenges along the way when training is everywhere is cumbersome. But then the other thing was because in parallel, I was trying to make sure I had career development built in and I could actually have science published during that same time while I was doing clinical training. I think it does add extra time because you're doing your clinical work, but then you use your nights and weekends to catch up with science.
And that's how we do it in most of the parts of the world. I have the feeling. And have you ever knew you wanted to do the cardiology, or very thinking that some other internal medicine specialty would be for your? How did you get to cardiology?
That's a very good question because I think initially I wanted to do cardiology when I was training in India, and then I felt, oh, so many people do cardiology. I need to do something different. I'm being funny because I actually chose to do neurology and even went into that path for a year and then realized, no, I really do like cardiology. So I'm one who didn't default into cardiology, but who wanted to do cardiology, thought that the different pathway was possible, but then realized that I had such a great love for cardiology and what it can accomplish for patients and their lives and how it can modify that. So I actually transitioned out from neurology into cardiology.
Okay, that's an interesting switch, definitely. And you also mentioned it a little bit. So you started the research already during the clinical training, and you always wanted to be the clinician scientist. You knew that from the beginning.
From the very beginning. So when I was in medical school, I was part of a research track. So I joined medical school in the second year of our training. There was this national competition for young investigators, and the thesis was that you spend a summer doing a project. You submitted a project, and if you got selected, like there were a few people in the country who got selected, you were given a scholarship throughout your medical training to do science. And the good part is not that the one experience was enough, but it made me every summer spend some time doing one research project or another, and kind of showed me a full gamut of science and how exciting it is to see science mature. I did all kinds of science, bench research, translational science, epidemiology, statistics. I learned all of that, and I think each of them has shaped how I think about science now.
Okay, and this brings us to the next question. When did you start to focus on the AI science? Because of the big data, you said that you went through everything almost. So why did you stick to this one topic?
So, I during my clinical training, I realized that many of the discoveries that we make in translational sciences don't make their way to practice, and largely because of how care is delivered and the dissociation we see from scientific discovery to actual practice. So, I wanted to start doing practical science. So, I started working on a domain called outcomes research, which is a clinical research domain, uses large data sets to infer practice patterns and quality of care and where we have lapses and how hospitals compare in performance. And that actually got me working with large data sets, extremely large data sets, large national level, multi-hospital, 5,000 hospitals, their administrative records and so forth. That gave me an appreciation of how much you can learn from this data. But I also got one particular challenge is that if I find there's a care lapse, I was never able to go back and figure out what might be the cause of a care lapse. So during my transition out of training into faculty, I actually wrote a grant using deep learning to extract signatures of when is somebody not getting appropriate guideline-directed medical care. I focus on heart failure, but this applies to everyone using natural language processing. This is before the time of ChatGPT, large language models. And actually, that was an extension from seeing that outcomes were poor and we had no ways to measure processes. So I started using EHR to measure processes, learned deep learning in that process, and then expanded the work into other AI domains, seeing where there are gaps in care.
Okay, that's quite a big, big beginning. And during your journey, definitely all of us are aware that mentors are very important. Yeah. So did you meet some mentors you would like to mention that helped you, that shaped you the way you are now?
I think along my career, there were mentors at my medical school who actually played a small but say very significant role in pushing me forward in this journey. I think during my residency training, there was mentor Dr. Sakit Tirocha, who was outcomes researcher. His I would say biggest accomplishment, biggest I would say push for me was actually this idea that I should be thorough. I should be dedicated, but not only just like push for a fast study paper, but like really engage in science, know the data you work with, learn to analyze the data yourself, learn the analytic platform, learn the science, then write the paper well, sell the science in a way that somebody can actually follow. And I learned that journey part from him. During my fellowship training, I had Dr. James Lemos and others who were very foundational in helping me learn how to present effectively my science. And then I met during the fellowship training Harlan Trumbull, who's the current editor-in-chief of Jack, and was my mentor during my fellowship training, even though I was at UT Southwestern and he'd always been at Yale. So we kind of worked remotely for several years. Then I moved to actually be closer to him. And then over time, I kind of crafted a different path from him, but he's continued to be a source of support.
Okay, so many people helped you, definitely. And during your journey, you received several prestigious awards and prizes, including the American College of Cardiology Young Investigator Award, the Francois Abboud Young Investigator Award, and several others. And among all of these prizes, is there one simple one or one specific one that takes place in your heart?
I think it's such a challenging question to answer because when I applied for many of these, they were like the biggest thing in that moment, and I really enjoyed the experience that they offered. I think the ACC Young Investigator Award was definitely very an important one in my life because it was while I was graduating from my clinical training and research to clinical training time, and they did a terrific job of curating the meeting and the science, and I really enjoyed the experience. I think the one that I think was maybe more promising, there's this major grant that I got, the Doris Duke Foundation Award, which I think actually not only came with an award, but like several years of research funding. And that allowed me to really go from being, an early career scientist to make that leap into an established investigator. So I've been very helpful and very thankful to Doris Duke Foundation.
Okay. And this means that right now we are still the young scientist, right? At the same time, you are the director of the cardiovascular research data laboratory, and you have founded this laboratory. So what is this laboratory about? What do you do, and what are the current projects you're most excited about?
Yeah, so when I got to Yale, I really wanted to build a team together who actually had shared ideology, and the shared ideology team is we want to do actionable science and data science, not merely discovery but action. And I think what we've done so far is assemble a group of now close to 15 people, which come from different walks of life. Some are clinicians, some are clinician data scientists, some are pure data scientists, some are pure scientists, epidemiologists, statisticians, project managers, project coordinators, all working together to do end-to-end in science. And I think projects we're very excited about are leveraging easy data streams like electrocardiograms, ECGs, and wearable devices, especially at large scale to diagnose undiagnosed disease. So things that are like really actionable, but are under the surface and very hard to like pick up.
We want to take the actions in order.
Yes, exactly.
So let's now shift the gear and let's move to this area. So I have to say that today we had a wonderful presentation of yours at the EAS Congress. And of those who haven't seen it, it was in the eHealth AI and the Big Data section. And we highly recommend checking it out because there's a recorded version of this lecture as well. So it's definitely worth of the time. And within your profile page on the Yale School of Medicine, you said that you are interested in digital phenotyping of cardiovascular disease. So could you explain to our listeners what this digital phenotyping means?
Of course, you and I can think of conditions in some key categories. So I present heart failure. We think about the symptoms that somebody presents with, their presentation, their signs that you would listen on an exam. But what are these signatures of heart failure that exist on modalities outside our vision and our examination? So we do an ECG, but we can see, okay, there's a bundle branch block. We see an echo, there's a no EF. We want to better understand whether there's additional signatures of these diseases that precede all of the clinical phenotypes that you and I can really pick up on. So idea is that using different data modalities that capture aspects of our physiology to pick up pathophysiological signatures that are present on digital sources. And then we can deploy them widely to pick up disease in an earlier disease state because we have noticed that these signatures emerge way before clinical disease emerges. That's the focus on digital phenotyping.
That's the digital phenotyping, so that in the digital signature of the disease, not only the common signs.
Yes, exactly.
Okay. And another major focus of your group is the personalizing the clinical trial result in one of your previous interviews, you have said we want to create tools that will help physicians decide if a treatment would benefit the patient in front of them. So could you walk us through what you are aiming to achieve in this field, and how does your approach differ from more traditional methods like the subgroup analysis or just the this typical method?
No, so some of our early foundation work led by one of our postdoctoral fellows, Evangelos Economou, who's actually presenting later today, was around phenomapping, this new approach that we developed. And the concept is this, that if you are a person in a clinical trial, there are other people in the clinical trial that look like you, and there are many people that don't look like you. Because, you might be a male, 30 to 35 years old, who has a certain set of comorbidities, their blood pressure is certain lines. When we do subgroup analysis, you can only do a few groups, men versus women, race groups or like clinical groups. But I have all those together. I'm a male, I'm, between my 30s to 40s age group and everything. So all that is part of like my entire constitution. So how do you build signatures that apply to me that not only capture that I'm a male, but also all of the things that come along with it? So we build these advanced tools where we place a person in a trial and assess other people in a trial that look like that person and assess the effect of the therapy that is as a function of all their characteristics. So creating essentially an counterfactual. So if in a trial, I got a treatment and you resembled me on many, many features and you got the control, we compare the treatment and control differences among similar patients in a large trial. And then we repeat this experiment across the trial to build tools that can generalize outside the trial. And the goal here is that you can actually pick up complex phenotypes and use them to guide personalization therapy. Because even in a trial, you notice that only a handful of people actually have events. And events also happen in the control arm, also happen in the treatment arm. It's not like the treatment arm is completely event-free, like that everybody's in. So there are people who are getting events in the treatment arm. So there are people who are not getting events in the treatment arm. There are people in the control arm who are also not getting events. And we want to see what are the signatures of people who selectively have features that have benefit from the treatment versus the control.
And this is the concept of digital twins?
Yeah, this is the concept of digital twins, as well as this concept of phenomapping that we championed initially.
Okay. And what kind of clinical trial data are you using? Or are you now using on the ongoing trials? So are you also going to pass to the already finished trials?
We started with finished trials, often finding a pair of trials. So one trial we'd use for development and then show the signature generalized to a second trial. We used the sprint trial of blood pressure lowering and had a study in Lancet Digital Health a couple of years ago. We used the sprint trial to find a signature of who benefits most and put that signature in a core trial, which is actually a null trial, and found that the signature of benefit from the sprint generalizes to a core. People who benefited from therapy in sprint actually benefited from therapy in a core as well. Then we also did diabetes studies, specifically one on cannabis was involved Canvas trial. And we used Canvas and Canvas R to similarly show a signature. And we've done some work in chest pain assessment too, published in the European Heart Journal. There's our first paper in this domain, and found people who come in with with stable chest pain, whether she was a CT or a stress test, and we found who benefits from it. And it's a tool called Azin. And all these tools are actually available on our website called cars-lab.org/tools. And you can find all these tools there.
Okay, I can recommend this personally. I've already run through this page and there's a lot of interesting stuff. And now shifting the gear even further to the intersection of AI and cardiology. You are also the co-founder of the Insight AI because you are developing tools, and this is one of the tools that is going now more to clinical practice, right? And this tool, the Insight AI, aims to detect ATTR amyloidosis from the ECG data. And some of your research even showed that conditions like left ventricle systolic dysfunction can be detected from those wearables like smartwatches. So could you tell us more about this finding and what lies ahead for this technology? And do you see a future where wearable data are used for the routine cardiovascular screening?
Perfect. So I think, I set up Insight AI with some of my collaborators a couple of years ago, with the goal that we didn't want to stop at publications. We wanted to go to practice. And the challenge is that when you build stuff in the health systems, you can do a lot. So I try to do in academic system. I try to do all of that in the academic system because there is commercial interest is not what's driving our work. It's the impact we have. But the impact is limited unless you can get FDA approval or approval from the regulatory agency. And the major thing that we're doing is actually taking the tools and actually using experts who are in the outside the academic space and using their expertise to take the tools to the FDA and take them to like getting approval from clinical use, getting the mark that is essential for clinicians to trust that this is a valid technology. And again, we can build tools, but unless they're cleared as devices, which they have to be, it cannot be provided to clinicians.
So that's the reason why to start the startup, right? To
Yeah.
go through this process is to move
Yeah,
the side to the FDA. Okay.
Yeah, I mean, you could technically see like if there are existing startups who are willing to take the technology on and then see this through, that's great. But I felt that there's some unique aspect of technology, and I wanted to see it through, and I also want to learn the process. I think there's a lot of learning involved in how to scale up everything.
And speaking of this, how much do you think this will really take in the future? Will it be in 10 years, 20 or 50 years to have all of these approved and used in the clinical practice?
I mean, I think
Just your personal view. Yeah.
I think it's going to be sooner because the FDA has already cleared two AI ECG tools, not ours, but other groups that use signal or raw voltage data, including one from including focusing on hypertrophic cardiomyopathy and one on LV dysfunction that have been developed by other groups. And I've noticed that the FDA is very keen on getting them out, but so in getting the approval process be seamless. But then we also found that the Center for Medicare and Medicaid Services, which is one of the largest public providers in public insurance providers in the U.S., actually started reimbursing for some of these tests as well, which is like they will provide coverage for them. And in conversations with many folks in the EU as well, and here in London, the goal has been that people are trying to figure out what's the best way to reimburse for this at a case discovery level or deployment level. But I think once we figure out the mechanics and how much it costs to deploy them, which is honestly not that much, I think it's going to be in practice in the next 5 years.
Okay, so that's a very soon future, actually. And now that we are going to the end of the podcast, right now we have heard a lot about the success stories, but also within the podcast, we have something we call the graveyard of ideas. It may be the story of any grand proposal, any idea that simply didn't work out, because we want our listeners to understand that the failure is the part of the process. So do you have any story like this to contribute to our graveyard idea?
No, I mean, I think there are many, and I also don't feel like there's anything permanent about any idea not working. It's all about moment in time. Like some ideas you have and they don't work in that time, but have brought back ideas 5, 6 years later. So one of the ideas that I think would have gone in the graveyard, and I'll give an example, is that we actually had this idea of digitizing the entire quality measurement approaches in health systems. So currently there are registries that are manually filled out by abstractors, trainees, they fill out the case report form. And I want to digitize that. But initially, one, there was less appetite. Second, the technology was so slow that actually building tools for each element would be so expensive. Like, if you have to just capture, somebody had shortness of resting exertion, like tapping that from every node, knowing that it's current or not, that kind of stuff becomes very challenging. And I really said, okay, this is going to be too cumbersome to do. So kind of a graveyard of ideas. Like you could think about a future where registries are fully digital and scalable, but that wasn't going to happen.
But you can dig up the idea later, right?
Yeah.
You can now put it to the graveyard, but you will dig it up later.
Yes, and that's what happens. So when large language models came around, we could dig it out again. Because now with the advent of very advanced large language models, we can parse the entirety of we don't have to build very specific models in large annotated data sets. So nobody has to go and mark charts, short is present, not present. We can actually let the test, let the tools parse the text out themselves and then do a little bit of improvement and actually go really far from that.
Yeah. Okay, so thank you for this point of view. And within the podcast, we also wanted to inform our listeners about the possible open positions in the different academic institutions, and not only about the position, but how does it work. So how does it work in your institution? Do you open the postdoc and PhD positions, you advertise them, or do you recommend somebody just to write to you and ask you?
I think it's a mix of things. It's a mix of things. Often we would open up positions, but many of the people who are currently there, first had the background and the interest. So in a sense, they're the right interest. They had looked at some, and they actually had, they were willing to spend a couple of years, 2 to 3 years with us. They were doing anything less than that ends up being less useful for building a new skill set. We typically, I would say, take more people in the postdoctoral path than the PhD paths. But if they're PhD student, I would say this: if you are an institution that allows you to do part of your training elsewhere, or you have a competitive grant that you get in your institution that allows you to do the training elsewhere, you're a very competitive applicant, then you should reach out directly and not wait for open positions. Because most open positions come with funding tied to them. But if you have some other avenues supporting the part portfolio, many people have started like that. So there is a student from the Netherlands who spent 6 months of his PhD with us, and now is a full-time scientist in our group. And so there's a lot of those pathways. But yeah, we put out postings, but often those postings fill out before they are pushed out because there are other people who have been in the pipeline before.
Okay, so thank you very much, and thank you for the whole interview. This was an incredible interview for me, the eye-opening, the close future coming to us. So thank you, Dr. Khera, and also a big thank to all our listeners. And if you enjoyed today's episode, we encourage you to subscribe, leave a review, and share AtheroTalk with other colleagues and peers. And until next time, thank you for listening. And once again, thank you, Dr. Khera.
Thanks for having me.